Hello friends, welcome to CEC live lectures. I am Dr. Pavitra Bharadwaj and I am working as Associate Professor in the Department of Computer Science in Jesus and Mary College, University of Delhi. So friends, this is our series on data mining, and the previous lecture of this series we had discussed about the technique of classification analysis. Actually, we had introduced the technique of classification analysis, and in this lecture also we are going to take it forward. So we were talking about, the process of how the classification model is built, the general framework, which is used for classification analysis. So we had discussed about, the topics of induction, we had talked about deduction, and we were saying that, any good model, which is being developed should be actually, using different data sets for induction. Induction basically means the step in which the model is built, okay, and deduction basically means that you are applying the model for testing the test instances or testing your data, right. So now when you are using a model for this kind of purpose, so we also need to talk about the performance of the model, right. That is how accurately the model is able to predict what it is supposed to predict. What it is supposed to predict? It's supposed to tell you the class labels of each instances, right. So what is the accuracy or what is the criteria for performance of a model? That it should predict the labels which are actually matching with the true labels of the instances. Now this information of how to evaluate the performance of the model, this can be summarized in a table, and that table is known as a confusion matrix. So it is called as a confusion matrix. So if we look at the confusion matrix for a binary classification problem, so each entry in the confusion matrix, say entry is Fij, it will denote the number of instances from class I which is predicted to be of class J, okay. So if we say F01, it means that the number of instances which were actually belonging to class 0, but they were incorrectly predicted as class 1, okay. So in the confusion matrix we can see that there are two main columns which are saying the to classify the predicted class, right. So where it is F11, it means that the actual class was also 1 and the predictive class was also 1. So this is the correct prediction. But in the next cell, if you see, we see F10 where the actual class was 1 but the class which was predicted by the model was 0. So this is an incorrect result. Likewise, in the second row also, we see that there is an entry F01. 01 means that the actual class was 0 but the predicted class was 1. So again this is an incorrect entry, incorrect prediction, whereas in the second cell in the second row we see F00, that is the actual class was also 0 and the model also predicted the class 0. So this means that F00 and F11, these are the correct predictions, whereas F01 or F10, these are incorrect predictions of the model. So looking at this table or creating this kind of a table, particularly we are talking about binary classification problem. What is binary classification problem? In which there are only two classes which can be defined, either class 1 or class 0 or any other class for that matter. So the instance will belong to either of the two classes only, right. So here this table is a perfect indicator and is a perfect tool for evaluating the performance of the classification model. So now if you want to find out the number of correct predictions made by the model, so it will be F11 plus F00, and the number of incorrect predictions will be F10 and F01. So we will find out the total number of correct predictions and the total number of incorrect predictions, right. So the confusion matrix actually, it provides information which is available which is required for determining the performance level of the classification model, right. So if you summarize the information into a single number, then it will make it more convenient to compare the relative performance of the different models. See, because we are going to develop different models and based on the classification model. So we want to compare the accuracy of different models. So how do we do it? We need to find out an evaluation matrix which is known as accuracy. And what is accuracy? How do we define accuracy? It is defined as the number of correct predictions upon the total number of predictions. So the number of correct predictions in the example case that we took was, and then you divide it by the total number of predictions which were made. So the correct predictions were F11 plus F00, and you divide it by the total number of predictions. Then you also want to look at the error rate of the model, right, because that's also an important metric which will define how the classification problem has been solved. What is the percentage of error? So error you will find out by taking out the number of wrong predictions divided by the total number of predictions, right. So accuracy and error are two complementary metrics. So if the accuracy is high, the error rate will be less. If accuracy is low, it means error rate will be high. So we are aiming at the model which will give us the highest accuracy and the lowest error rate, right. So basically we want to attain high accuracy and low error rate, and that is the model that we are going to look at. Now the first model or the first classifier that we look at, which is based on classification analysis, is the decision tree classifier, right. So decision tree classifier is basically a very simple classification technique, right. So again we are looking at the problem of classification of vertebrates, right. If you remember, in the last lecture we had taken this example where we have a list of a data set of vertebrates and we are going to classify them as mammals and non-mammals. So this is basically a multi-class classification problem because it will result into multiple classes, but we are converting this problem into a binary classification problem by only dividing the vertebrates as belonging to two classes, that is mammals and non-mammals, right. So it's this example that we will be using for building a decision tree. So we will solve the classification problem by asking a series of carefully crafted questions about the attributes of the test instance, and each time we receive an answer we will ask another question until we can conclusively decide on its class label, right. So we ask first question whether it is, say, cold blooded or warm blooded, right. If it is cold blooded, obviously it is not mammal, but if it is warm blooded, then we further need to ask some more questions like this. So a series of questions and the possible answers, then they will be organized into a hierarchical structure, and this hierarchical structure which we get is known as a decision tree, right. So the tree basically, it will have three types of nodes. The first node is a root node. Root node means which is the first node from which the tree starts building. So it will have no incoming nodes and it can have 0 or more outgoing nodes. So root is the first node of the tree. Then we have internal nodes. So internal nodes will have one incoming link and it can have 2 or more outgoing links, because you are going to ask the question and depending on the answer to that question you can have 2 or more outgoing links. And the third type of node is known as the terminal node or the leaf node, right. So leaf node basically will have exactly one incoming link and no outgoing link. So leaf node basically is where the classification problem is solved, where you actually are able to identify the class or you are able to assign a class label to that particular instance, right. Now for example, if we take this decision tree for the mammal classification problem. Okay, so the first question that we ask is about the body temperature, right? Whether it is warm blooded or it is cold blooded, right? So if we have an instance in which we want to know whether the animal belongs to a mammal class or it does not belong to mammal class, so then the first attribute or the first question which is asked is about the body temperature. If the body temperature is cold, then you come to the leaf node saying that it is not mammal. So this is the class identifier which is given, right? Now in this case the body temperature node is the root node because it does not have any incoming node, but it has got two outgoing link, right? So now the second answer which you get is warm blooded. Now if it is a warm blooded, then the next question which needs to be checked, or the next attribute which needs to be checked, is whether it gives birth or not. So if the answer to the question gives birth is yes, then you come to the leaf node saying that it is mammal. If the gives birth question says no, then you come to the leaf node which says it is not a mammal. So gives birth question is actually an internal node, and where you are able to identify the class as mammal or not mammal, that is actually the leaf node. So wherever the class identifier is coming, that becomes the leaf node, and after the leaf node there are no outgoing links. So that is where the classification problem is solved, where the label has been identified. Okay, so the leaf node is actually associated with the class node, class label, and the non-terminal node. Non-terminal nodes means that the root node and the internal node, they are actually conditions. These are the testing conditions which will typically be defined using a single attribute like body temperature or like gives birth. So you will have one attribute which you will be testing in each of the non-terminal node. Now each possible outcome of the attribute test condition will be associated with exactly one child of this node, right? So for example, we said that the root node of body temperature, so it has got only two outcomes. Either it can be body temperature can be warm or it can be cold. So it cannot be more than two options which is given, right? So you start from the root node and we apply the attribute test condition and keep following the appropriate branch based branches which are based on the outcome of the test. So every non-terminal node you will test and you will go to the next level. So this will either lead us to an internal node, further which is going down, or if your, the condition is being met, then it will lead to a leaf node. Okay, so once a leaf node is reached, then we assign the class label associated with the node to the test instance, because the leaf node is your final outcome, right? Like for example, now this is a proper, particular example in which we are classifying an unlabeled vertebrate, okay, and if you look at this, the dashed lines will represent the outcome of applying the various attribute test conditions on the unlabeled vertebrate. So the vertebrate, we need to check whether the test vertebrate belongs to the mammalian class or it belongs to a non-mammal class. So again the same procedure is being used, that the body temperature attribute is checked. Now for this particular instance, the body temperature is warm, so you come to the the left hand side of the tree. So then you check whether it gives birth. So it does not give birth, so therefore it means that it is a non-mammal. Okay, it is a vertebrate which is a non-mammal, and probably this is a bird. Further, if you want to understand whether it is a bird or it is an amphibian or it is a what is it, then you need to ask another question, say whether it has wings or whether it is lives in water, it's aquatic. So you go on asking questions, and after each question that you ask, you will have conditions, and ultimately the leaf node which you will get will give you the final label of the class. Okay, so this is this is an understanding of how the tree classifier works and what are the different labels which can be assigned to the tree classifier. Now using this tree classifier, we will actually build an algorithm to create a decision tree, right? So there is a basic algorithm which will be built for the decision tree. Now many decision trees that can be constructed from the particular data set. It depends on, how you are proceeding, or what type of attributes you are checking. So it's very difficult to know that which is the best of the trees that have been developed, right? Because the same data set can give you multiple trees. So what is the objective? The objective is to find an optimal tree which is computationally, less inexpensive, okay, and because what we are looking at is, we are looking at exponential size of the search data, right? So we want that the algorithm which we develop will have reasonably accurate, although it may have suboptimal decision tree in a reasonable amount of time, right? So we are looking at accuracy, we are looking at less amount of time, although our decision tree that we are going to develop, it may not be the optimal one, because the optimal decision tree, it may be computationally very expensive. So we don't want the best tree, we want a tree which will give us accurate results in less amount of time, okay. So now the algorithm which are employed are basically using a greedy strategy. Greedy strategy means that the tree will grow, the decision tree will grow in a top-down fashion by making a series of locally optimal decision about which attribute to use when partitioning the data. So after, it is actually a recursive method which we'll be using, because after every attribute is tested, the next attribute to be chosen, or the next question which is to be asked, how it is to be chosen, will be decided by the algorithm, okay. So this is one of the earliest method, and this is used in a very popular algorithm which is known as the Hunt's algorithm, and the Hunt's algorithm is the basis for many current implementations of decision tree classifiers, including the ID3, the C4.5 and the CART classifiers. So basically we are going to look at how the Hunt's algorithm can be used to build the decision tree, right. So the Hunt's algorithm basically is a decision tree which is grown in a recursive fashion. So what is recursive? Recursion, if you remember, in programming also we have done that recursion means that a function is calling itself, that is called recursion. So the tree which is initially contains a single root node, okay, and the single root node is associated with all the training instances, okay. So that is the basic question in which all the instances are going to fall, right. That is the first or the most generic question. So every instance will have an outcome of the root node, whether it will be yes or it will be no, right. So if a node is associated with instances from more than one class, then it is expanded using an attribute test condition that is determined using a splitting criteria. Now what is the splitting criteria? We are going to ask the question based on the attribute, and then we will split the data into two classes, either yes class or it is a no class. So a child leaf node is created for each outcome of the attribute test condition, and the instances which are associated with the parent node are distributed to the children based on the test outcome, okay. So what we are doing is that the ultimate node, which is the child node, or which is the leaf node, we will create that as an outcome for the attribute test condition, and then we will move backward to distribute the children based on the test outcome. Every node we will test the condition, we ultimately reach the leaf node, and then we move backwards to check the different outcomes which have resulted. So this node expansion step can then be recursively applied to each child node as long as it has labels of more than one class, okay. So you know, if your child node, whatever child node you are getting, it has got labels which belong to, which can pertain to more than one class, then you will again ask questions, that is recursively you will again ask questions, and then this will be expanded. So your node will go on expanded. If all the instances associated with the leaf node have identical class labels, okay, then the node is not expanded further. Why? Because it means that now you have received the, you have reached the leaf node where you have assigned a class label to each of the nodes. So each leaf node is assigned a class label that occurs most frequently in the training instance associated with that node. So we have our training data set, the test data set. In that, whichever class label is occurring most number of times, that will be assigned to this particular node. Okay, so now in this case, we will look at the problem, that is the borrower's classification problem. So we had seen that, you know, in the borrower's classification problem, we had taken the personal data of the borrowers, and looking at the personal data, we wanted to ascertain whether, you know, assign a class, whether it is a defaulter or the borrower is not going to be a defaulter, right. So these are the four, you know, the three different attributes on which we are going to check the, or on which we are going to build the decision tree. That is whether the borrower is a homeowner, okay, whether the borrower is married, and what is the annual income of the borrower. So we will build the decision tree on a step-by-step basis using the Hunt's algorithm, right. So the tree initially contains only a single leaf node, okay. This node is labeled as defaulted as no, right, because the majority of the borrowers did not default their loan payment. So if we look here in the data set, we can see that most of the borrowers, they have a default is equal to no, although we can see that out of 10 data sets, 3 have got yes also. So it means that defaulted is equal to no belongs only to 70% of the data set, 30% belong to defaulted is equal to yes. Okay, so the training error of this tree where we say defaulted is equal to no is 30%, right, because we know that 3 out of 10 have already defaulted is equal to yes. So therefore now what we need to do, because there is an error in this, so we need to expand this further. Okay, now when you are expanding it, it will contain training instances for more than one class, because now we have two classes, defaulter is equal to yes and defaulter is equal to no. So now what we are going to do next is that we will ask another attribute, we will check with another question, that is whether the homeowner attribute will be chosen to split the training instance, right. Now the result will be a binary split on the homeowner attribute, that is whether they are homeowners or whether they are not a homeowner, and based on homeowner or not homeowner, then we will assign the class defaulter is equal to yes or defaulter is equal to no, right. So if the person is a homeowner, then the person is a defaulter. If the person is not a homeowner, is the person a defaulter, right. So all the training instances for which homeowner is yes, you know, they are propagated to the left child of the root node, and the rest are propagated to the right child, right. So we have different instances. So everywhere there is the homeowner is yes, you will move them towards the left side of your tree, right. Then we see in the next step, we see that, you know, you have homeowner is equal to yes and then the defaulter is no, and the cases where homeowner, the borrower is not a homeowner, yet the defaulter is no. So Hunt's algorithm will recursively be applied to each of these child, that is defaulter is no, and to the left side and to the right side. So when left child becomes a leaf node labeled defaulter is equal to no, now since all instances which are associated with this node have identical class, then we will say labeled as defaulter as no. The right child has instances from each class label, hence we split it further. So the right side will be splitted further, the left side we will leave. So the resulting subtrees will, what we get after expanding will be this. So in the step 2 we get the subtrees like, homeowner, you check whether it is yes or no. If it is yes, then you say defaulter is equal to no, you reach a leaf node. But if it case no, then you further ask the question about marital status. So we check for marital status, and again we recursively reach the same check, that is, marital status is married or not married. So then you reach the you reach the ultimate leaf node where you can identify the classes as defaulter is yes and defaulter is no, right. So you can divide the classifier like this. Now in this case, after you check for, in the third step when you check for homeowner and then finally the marital status, further you will check that whether the person has annual income within a particular range or not. So likewise, you check for one attribute, then you check for another attribute, you check for the third attribute. Likewise, you will go on building the tree until you get the last class label in the leaf node, right. So this is about how Hunt's algorithm can be used to build a decision tree. We will be continuing with our discussion on classification analysis in the following lecture also. Please keep watching CEC. Thank you.